we created the random demands in the earlier video segment, but actually I would say it would be more appropriate to give the mean demand instead of fixed value 10 here. I can select the value from this cell just to have an option to change it, and I will change the reference to fixed with dollars by clicking F4, and now I will copy it and paste here, right? So this selecting F4, and I will be able to later on evaluate what if I expect the demand to be 11, for example, on average, what will it change for the simulation? But for the time being, it's 10, so it really is the same simulation as before, just with one number, one parameter used from here when generating the average, the actual demands in year 1, 2, 3, and 4. So in order to simulate now, we need to mark the output, right? This net present value should be marked as an output. So this is the second button. First, click on the value, net present value, 59,000 in my case, but right, the formula which calculates the net present value, and select output, right? And we can, of course, call it, let's say NPV, right, as an output. Click OK. Now this is marked as an output. If you recall, there is a function risk output added to the value. The value remains the same. Risk output doesn't change. It just indicates that the simulation add-in should trace this output value when it simulates. And now I'm ready to simulate. So let's say I simulate for 1000 iterations at the default value. I'm going to click simulate. I'm ready to simulate. And you see the 1000 iterations were simulated actually very quickly. This is a relatively small simulation, right? And I get the distribution, and I can already see, that it is possible that I get less than €0, or right. So I may have some losses, or I may have some significant profit from this operation. I think we can afford to generate larger numbers. Actually, I can see the minimum here, maximum, and the mean, right? And it also shows you, notice here, 90% confidence interval. So basically what that means is that the mean, 26.7, right, 26,793 euro is correct, is in the range of plus 1,187 from this and minus 1,187 from this, with 90% chance. So this is 90% confidence interval defined by just this one delta value. There are other statistics here displayed. So right, so you can see this could be, we see the distribution, but also some basic statistics. I actually want to generate a larger number of iterations because we can afford it, apparently. Let me try 20,000 again and simulate. And notice this is taking a little bit longer, but we're getting a much smoother distribution here, as you can see, right? And we can actually see minimum is actually very, quite a big loss, right? 61,000 loss maximum, but the mean is still around the same number, and the confidence delta, you see, is just 261 euros, so it's much narrower. And we are, I think, ready to answer some of the questions. So the first question that we had is, what is the expected net present value from this investment opportunity? The answer, we can, of course, put it in Excel, but we can also read it from here. It's 26,794 plus minus 261 if you want 90% confidence interval, right? We can also calculate it using certain functions. So let's put this first. So let's say this is the NPV, and I'm going to say the mean value. Let's say the mean will be here. This will be confidence interval low and confidence interval high, right, value. So we can, of course, select this from the output. There is a function called simulation result risk mean, but I can actually type this function myself. If I remember the parameters, risk mean, and then I want to indicate, I want the mean value of the NPV, and you see it's the same, 26,794, and I can now have confidence interval for the mean low, this is risk CI mean. And here we have to say that we want, let's say, this net present value. Then the confidence interval, let me just hard code it here, is 99%. And I want lower limit. I believe this is the value is true, right? This is the lower limit of the confidence interval, and a similar function I need here for high, but I will just change it to false, right? So we see that the mean payoff from this investment should be somewhere in this range, right? 26,380 euro to 27,200 euro. Now, is the mean the right way to evaluate this? If this was something that we do repeatedly, like this kind of investments, then, right, in a repeated game, looking at the mean and its confidence interval is the right thing. However, if this is just a one-time situation, and if we have a big loss, we will actually be in big trouble, then looking at something like what's the likelihood the net present value will be negative or zero, right? This is quite important, right? So we can ask ourselves what is the probability that NPV is smaller or equal zero, right? And this can be calculated using a function from the simulation result values, which is called risk target, right? Risk target, I will use the dialog box. For this value, we say target zero, and let's see what's the probability that we will get negative value, and the probability if we convert it to percent is 11.4%. So this is answering the second question. There is 11.4% chance that there will be a loss from this investment. So there is quite a significant, though small, probability. Notice we can actually see it also in the output. If I right click here and select explore browse result, we will get the same chart that we had before. And notice, right, we can see that zero or less, there is a certain distribution here of the results that are zero and smaller, right? So this area that you see for this part of the chart, we can actually try to select it, right, somewhere at around zero. Yes, there it is zero, right? And going here, this probability here is 11.4%. We can see it here, 11.4%, right? So it must be the rest is 88.6%, right? This is the answering. We have answers for question 1 and question 2. And question 2 is actually, this answer is more important if this is a one-time investment and we are afraid of losing money on it. So this is an interesting question.